Hello and welcome to day 6 of Advent of Code. Today we're going to go over the solution for that, so let's jump into it. I actually felt like day 6 was a lot easier than day 5, but anyway, we're gonna still talk about it. Let's look at our problem description. So I simplified the problem description a lot here. Let's actually look at our parsing as well so that we have some frame of reference here. But the input is a group of individual answers. So you can see this is one group, this is one group, this is one group, and each of the lines are individual answers. You can see this is one person answered A, one person said B, one person said C, and yeah, we're supposed to figure out like either everyone agreed or everyone didn't agree on each of these alphabetical characters. And I actually use the fact that they're alphabetical characters to make the problem a little bit easier to solve in SQLite, but we're not going to use that fact here. We actually don't care whether these are letters or numbers or whatever. And for part 1, we want to sum for each group the number of unique answers. So looking at these here, there was only one user, but they had 3 unique answers, so this would have been 3. This was 3 different users had, the answer A, the answer B, the answer C. So this is, still 3. This one, they both answered A, so A only gets counted once, but B and C also get counted, so this is also 3. These, everyone answered A, so it's only 1, and this, everyone only answered B, so it's only 1, and we add all those together, you get 3 plus 3 plus 3 is 9, plus 1 is 11, so that's kind of what we expect for part 1. Part 2, we're going to sum up the only agreed upon ones. So in this one, there was only one person, so all of them were agreed upon. So the answer, this is 3. Nobody agreed here, so it's 0. These two only agreed on A, so it's 1. This one, they all agreed on A, so it's 1. And this one, only one person, so it's 1. So 3 plus 0 plus 1 plus 1 plus 1 is 6. And so that's what we would expect for this input. So those are the 2 inputs. Let's do the parsing first. Whenever I see like unique answers or stuff like that, my brain is immediately jumping to working with sets. And so what we're going to do here is we're going to parse each group as a list of sets. And so overall, we'll have a list of sets. So let's get started with that. So the first thing that I did is I split things into individual groups. And so we'll have our return value here. And things were split by a blank line, so again, that should give us a hint to use backend. So for group S in s.split backend, so that gets us our individual group strings. We can get individual users out of our individual group strings by using split lines. So for user S in group s.split lines, and then so we're gonna have our group as a list as well. And so for each of these user S's, we're going to create a set out of all of their different choices here. So group.append set user S. We actually use a neat fact about sets here in that a set of a string will actually just give you each of its unique characters because a string is an iterable of 1-length strings. So we're using that fact here. And then finally ret.append group, and then return ret. And so this should give us a list of lists of sets. And if we run this, 3 parsing.py, the output is a little bit different due to the way prettyprint works, but it's essentially the same as what I got here. I also manually crafted this output, and so my output is sorted instead of this one here. But you can see we have the sorting, we have the parsing done here. Now note, I actually took a lot of shortcuts in my implementation of this, so I didn't actually use this parsing. And I'll show you that in a second when we get to implementing part 1. But that's the parsing, not too complicated, just make things into sets, essentially. So let's jump into part 1.py. I've actually kept the input here so that I can show you my shortcut to this problem. But when we're dealing with sets here, this is actually pretty straightforward. So total equals 0, and then for what? For group in input, and then we want to figure out the total, all of the sum of these. And so what we're actually doing is ORing all of these sets together. So if we do, or unioning, I guess is the set word. So if we unioned A with B with C, we would get a new set that's ABC. And then we would look at the length of that to see the total number of unique things. And so in this case, we're going to use an accumulator. Accumulator equals an empty set. We're going to start with an empty set, and we're going to OR everything into that. So for user in group, we can do accumulator OR equals. So this will union the user into that. And then finally, we can do total plus equals length of accumulator. So this return total. So within each group, we will get out, one total. One thing that I did to make this debugging a little bit easier is to print len accumulator. That way we can see each individual group. We didn't really have to do this much on previous puzzles, but 1.py. And so you can see here, these are each of the individual groups, and then finally we get our answer, which is 11, which is what we expect there. Now, I actually took a bit of a shortcut here based on the input. I noticed that we were looking for uniques across the entire group, so it didn't actually matter that we had individual users. So what I did is I took this whole string and just made a set out of that. So this was my compute, I don't know, slightly easier approach. And but I had to do a separate set of parsing here, so my parsing was different. So I did for group S in input s.split backend. So again, using that same trick, total equals 0. And I just did total plus equals length of set of group S. But we don't want to count the new lines in here. So that new line character will be included. So if you do set of A backend, B backend, C backend, you'll notice you get A, B, C, and the new line character. But we don't want to count the new line characters. We're only concerned with alphabetical characters, so we have to subtract out new line at the end. I actually, in my submission that I submitted, I also subtracted space, because I didn't actually look at the input and didn't notice that they didn't have spaces in there. That actually does nothing, so we do that there. And finally, we can return total. I don't know if this is easier. Maybe compute cheaty. Print compute cheaty. Then we should see if we run that we get 11 for both of those. So this takes a little bit of a shortcut. If we look at the overall runtime of this, it's actually a little bit tricky to see this. But this is O of n on the number of groups, so saying n equals groups. And this is O of m, where m is equal to the users in a group. And normally you would say, okay, well, it's n times n, but m is super variable here based on the number of things in the group. But we can take both of these and say, oh, well, it's linear over the number of inputs, line inputs. So overall, this one actually works out to be O(n). This is, equally tricky to see what's going on here, but again, like this is O(n) over n equals the groups, and this is O of m, where m is the characters. But again, it's like order n over the number of lines, so these are both linear solutions here. We do use a little bit of space for both of them, but that's based on how our parsing is. And again, our parsing could be done lazily so that we don't actually use any extra space here. We would really only use space for our accumulator here and our intermediate set here. But anyway, that's part one. Part two takes this. Part two is actually pretty interesting. We can actually take our compute function here and reuse it a lot in part two. Let me open up part two just to see the description again. So the only difference with part two is we want the agreed upon answers, so where all of the users said the same thing. So if we open up part2.py, again, I have my input from before. I'm going to copy and paste our part one. And interestingly, we can actually solve this very, very easily by reversing our OR and accumulator here. So when you want to accumulate unions, you want to start with an empty set and then build up more things. But we're going to accumulate intersections. So with the intersection, we want to start with one of the things in our set and then AND it with all the other ones, or intersect it with all the rest of them. Instead of doing this accumulator like this, we are instead going to pick our first group user and then accumulate with all of the other ones, intersect with all the other ones. So we'll use and equals instead. So it's like a really easy way to adjust the first problem into the second problem. And if we run this, python3 part2.py, you'll see that we get our expected value, which is 6. But anyway, that's, let's see if I can fit on one screen. It is. Nice. So that's part 1 and part 2 for day 6, which I thought was a lot easier if you were thinking about sets. But anyway, hopefully this was helpful. I will see you again in the next one for day 7. Bye.